Hello viewers, welcome back to the channel Maths with Berlin. So this is the part 3 video of the Masterstroke series. In this series we solved various JEE advanced problems, and for today we have another problem with us. So I will be marking out the problem so that you can understand which problem we are solving today. So this is the problem that we will be solving today. Let us just magnify the problem so that you all can see it properly. So this is the problem we are talking about, right? So it's basically a question that is on binomial as well as sequence and series. So pause the video right here, give it a try, and then move on to the solution. So I hope you all have given a try. So let's just give a formal reading to the question. The question says that we have to assume a variable an such that it is equal to ln of 3 to the power n and multiplied by the summation of k equal to 1 to n, k square divided by k factorial into n minus k factorial, and this is the summation that we have to find out, right? Now before directly moving on to the problem, let me just show you one thing. What we have to do is we need to multiply n factorial in the numerator of the binomial term that is given. In the binomial term, what we will do, we'll multiply n factorial in the numerator and n factorial in the denominator, and we already have k square divided by this is k square divided by k factorial into n minus k factorial, right? So what this results into is we get this as 1 by n factorial summation of k squared into nck. Now you all can understand that if we find the value of this one, it will be very easy to solve the problem, right? So that is our first and foremost priority, to solve the value for this one. So that is the hint number 1, as you all can see. So for the hint number 1, we are just trying to solve this problem, that is k squared into nck. So what I have done basically is I have applied a property of binomial. So the property of binomial that is there is ncr is equal to n by r into n minus 1 cr minus 1. That is what I have applied in this step, in the first step, right? So that converts the k, right? The k term in the denominator and the k term in the numerator gets cancelled out, and we are left with a single k, right? After that, if you see, we have the following n that is there, that is a constant, right? So we can take this out on outside the summation, and we will be left with k times n minus 1 c k minus 1. Now what we can do is we can break this k into two parts, that is k minus 1 and 1, right? So right after that, what we can do is we can open the brackets, and we'll be having that k minus 1 times n minus 1 c k minus 1, and we have another n minus 1 c k minus 1. Now again applying the property of the binomial, right? We can apply this property of the binomial again, and we will end up with a simple binomial expansion, right? And this is already a simple one, so we can evaluate these two expansions as, with the help of 1 plus x to the power n. We all know that 1 plus x to the power n is equal to this, and thereafter putting the value of x as equal to 1, we get that the value of it is equal to 2 to the power n. So by the similar analogy, what we can say is that the value of this expression right here, this one right here, right, this is equal to 2 to the power of n minus 2, and the value of this expression that is there, we can get this equal to 2 to the power of n minus 1, right? So now moving on to the second hint. So for the second hint, we have that the expansion of e to the power x. So we need to know the expansion of e to the power x. It is just basically the summation of x to the power r divided by r factorial from r equal to 0 to infinity. We get this expansion by the help of the Taylor series, right? So I hope you had understand the hints right now. Now moving on to the solution. So before moving on to the solution, just pause the video right here, give this problem try again, and then see the solution, right? So for the solution part, if you see, what I have done is I have just basically said it to you, that is I have multiplied an n factorial in the numerator and an n factorial in the denominator, right? So that results into this expression. And now using the hint number 1, what we can say is this value is the value of this binomial is just equal to this. Now we can just open the brackets and we'll end up getting a very simplified expression for the summation of the binomial, that is this, right? Now we had also assumed that x is equal to ln of 3, right? Why did we assume it? Just because of simplifications, right? So what happens is when you put x equal to ln of 3, you will get the x to the power n on the outside, right? Now after that, what you can do is you can take x to the power of n minus 2 common with this term and x to the power n minus 1 common with this term, and you will end up getting these expressions, right? You will end up getting these expressions. Now x is a constant term, right? The variable term was x to the power n. This power was a variable. Now the power is not a variable in our problem, right? So what we can do is you can take this outside while taking the summation of a to the power n. You can take this x square and this x outside of the summation, and you will be left out with the summation of 2x to the power of n minus 2 divided by n minus 2 factorial. Now this ranges from n equal to 2 to infinity. Why is it 2? Just because when the values of n are 1, it is the denominator is not defined, so we have to start it from 2, right? So this is just equal to e to the power of 2x as explained in the hint number 2, right? You may follow the hint number 2. This is equal to e to the power 2x. Also the summation of 2x to the power of n minus 1 divided by n minus 1 factorial is basically from n equal to 1, right? This is starting from n equal to 1 to infinity. This is also equal to e to the power 2x, right? So that is what I have done here, that is e to the power 2x and e to the power 2x. Now what I can do is I can take the x into e to the power 2x as common outside the bracket, and we will be left with 1 plus x. So now e to 2x is equal to ln of 9, right? 2x is ln of 2 into ln of 3, and that is equal to ln of 9, right? So that is what I have written here, that is e to the power ln 9. Now that is just simply 9, and x is simply ln of 3, and 1 plus x is 1 plus ln 3. So by the help of which we will get the answer as, I think option B is the correct answer. So just let's check it out. Yeah, so option B is the correct answer to the following problem. So I hope you liked the solution to the following problem. Please do like, share and subscribe the channel for more such content, and please share it with your friends and all the peers so that they can also benefit it from here. Thank you everyone.